Welcome back. So now the next one has a product rule and a sum and difference. I put the product rule up there already, the shortened version, so I could squeeze it up there. We need to first deal with our product, right? And then we can take the whole derivative. Right? So we got a product there, which means got to use the product rule. Right? The first one is a theta, that is a variable like an x. And then we have sine theta. So we do have two functions there, right? Product of functions, right? So the derivative of theta is just 1, just like the derivative of x would be 1. And the derivative of sine theta is cosine theta, right? So now we can take the derivative. So g prime of x is equal to, right? So we can just take the derivative of 3 theta. Derivative of 3 theta. They had to put a 3 in front of it, not some other number. So the derivative of 3 theta is 3, right? Because the x would reduce, or the exponent would reduce by 1, and then you'd have theta to the 0 power. So the derivative is 3 plus the first, which is theta, times the derivative of the second, which is cosine theta, plus the second, which is sine theta, times the derivative of the first, which is a 1. So I understood there we multiplied by 1. Right? I'll even just put 1 sine theta. And we're done with this one because that's as simplified as it's going to be. Right? There's our derivative. And let's do one more. All right, so h of x is equal to sine x times cosine x. Right, so u is sine x and b is cosine x. Right, so derivative of sine x, that's cosine x. Derivative of cosine x, that's negative sine x. Got lots of sines and cosines there. Right, so h prime of x is equal to the first sine x times the derivative of the second, so that's times negative sine x, plus the second, which is cosine x, times the derivative of the first, and that's cosine x. All right, so this one was, just to help you out, this one was u, this is dv, this one is v, all look a lot alike. We can simplify that. Right, that is not sine x minus sine x, it's sine x times negative sine x. So that's just going to be, there we go, negative sine squared x. You got sine x times itself, that's sine squared x. And then times a negative 1. And then plus cosine squared x. And had that not been negative sine squared x, that would just have been 1. But alas, you cannot add sine squared x and cosine squared x. Because that's not a Pythagorean identity. So we're done with that one. Find the equation of the tangent line to the graph of g of t equals t squared times cosine t when t is pi 6. It's nice not having just pi all the time, or 0. All right, but first of all, let's take the derivative. All right, so u is t squared and v is cosine t. Derivative of t squared is 2t. Derivative of cosine t is negative sine t. Right, so I'm going to write over here, I think. Right, so g prime of t is the first t squared plus the derivative of the second, so that would be negative sine t, plus the second, and I actually will just write in the cosine t. And then put, whoops, we got way too many t's there. My throat is really sore. Just thought I would share that with you. Cosine t times the derivative of the first was 2t. And I'm just going to write it like this, only because I'm going to have to simplify it anyway, because of the negative sine t. I usually focus more on just making sure, and I think it's more important, you make sure you got all the right terms, And then you go back and simplify. And remember that these are all multiplications. All right, so this is going to be negative t squared sine t, right? Because it's just t squared times a negative 1 times sine t. And then this would be plus 2t cosine t. All right, and so we're going to evaluate when t is pi 6. Right, that'll give us the slope of the tangent line. So g prime pi 6, I should have given this one its own page, is equal to, I really should have given this one its own page. But I think yeah, it's stuck in there. It's stuck in there. Let's see if I can squeeze it in. All right, g prime of pi 6 is equal to, so this would be negative pi 6 squared times sine pi 6, and I could probably use the box above it a little bit, plus 2 times pi 6 times cosine pi 6. All right, so let's just simplify out that some of the numbers, and then let's talk about the trig functions. All right, so pi 6 squared is going to be pi squared over 36, and it's going to be negative. So negative pi squared over 36. All right, sine pi 6. All right, so in the first quadrant. All right, so pi 6, 180 divided by 6, 30 degrees, it's 30, 60, 90 right triangle, right? So anytime you have a sixth, a fourth, a half, or pi to an integer number, right? It's one of those special triangles, or it's a quad angle. All right, so this is 1, this is the square root of 3, and that's 2. All right, so sine pi 6 is going to be 1/2. And cosine pi 6 is going to be the square root of 3 over 2. All right, so we'll plug those in. So this is now just times a 1/2 plus, and we could simplify that. Actually, let's just write everybody in 2 times, and we'll do all the simplifying at the end. 2 times pi 6 times the square root of 3 over 2. And then finally, let's see how much we can simplify. G prime of pi 6 is equal to, I'd like to extend the page, but I can't reach it. Not since all that construction work seemed to mess up my projector. All right, so g prime of pi 6 equals, all right, so now this will now be negative pi squared over 72 plus 2's will cancel. So now we've got the square root of 3 pi. Now let's put the pi in front. That looks better. Pi square roots of 3 all over 6. Yep, that's our slope. So we would need a calculator to be able to simplify that any further than it is right now. So I tell you what, I'm going to stop here at this point, and in class we'll take out a calculator, so you're not just sitting here listening to me punch into a calculator. Once we get that's kind of hard to write that as our slope, and it doesn't simplify any further than that. But what we could do real quickly though is we need the y value, because we want that tangent line. All right, so we need g of pi 6, which is pi 6 squared cosine pi 6, which is going to be pi squared over 36 times the square root of 3 over 2, which is pi squared square root of 3 over 72. So not a single number here is very, very pretty. So in class, with a calculator, we'll get a decimal equivalent, so we can write an equation so we don't have 72 terms in one single equation. Right? But we did, the most important thing was be able to find the derivative, and knowing what to do when you find the derivative. After this, it's a plug and chug. but we'll plug and chug in class. All right, so it's a very valuable lesson we need to learn when we're introduced to the product rule. All right, so on your notes, it's page 211. We found f prime of x by applying the product rule to the function f of x equals the square root of x, blah, 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 x squared. It was back here, minus 3x plus 2, and it was, how did I get to remember it? I'm going to remember the one on top, not the radical one. So g prime of x is 3x to the 3 halves minus 6x to the 1 half plus 2 over x to the 1 half. Can I remember that? And then I promptly change the page and I go, what was that again? F prime of x is, well, I remember the 2 over x to the 1 half, but I forgot what the other two terms were. I told you I'd forget. It was 3 and 6, 3 halves, 1 half. Okay, I got it. Paying attention now. 3x to the 3 halves, and then 6x to the 1 half. I think it was a negative 2. And I remember plus 2 over x to the 1 half. All right, so we're going to rewrite it in polynomial form, and hopefully we get the same answer. All right, so f of x equals this would be x to the 1 half times x squared minus 3x plus 2. All right, and so that would be f of x equals x, so 4 halves plus a half, that'd be 5 halves, minus 1 plus a half, that would be 3 halves, plus 2x to the 1 half power. All right, so f prime of x equals, coefficient goes in front, 5 halves. Now I had a 3. It's making me feel not so good about myself right now. I'm hoping I'm going to be able to add something to it. I don't think so. I have 3 terms and 3 terms. I'm not feeling good about my answer over there. All right, so 5 halves x, because there's no error there, right? No. 2 halves and 1 half, that's 5 halves. Or 4 halves and 1 half is 5 halves. So 5 halves times x, and then to the 3 halves power, that's the same, it's the coefficient that was different, minus, right, so 3 times 3 halves is going to be 9 halves. And so this would be to the 1 half power, and then plus x to the negative 1 half. Not a single, all my exponents are correct, but nothing else. None of my coefficients. And this would be x, 1 over x to the 1 half. What went wrong? Let's take a look. See if we figure something out. And we might talk about it in class. Let's just make sure I didn't make a multiplication error, because there was a lot of multiplying on that product rule. Matter of fact, on that particular problem, there's the product rule, and there's just simplifying and taking the derivative. Sometimes just simplifying and taking the derivative might be the easier way to go, huh? But let's see, did I have an error here on my product rule real quick? All right, or am I multiplying? All right, so the first was definitely x to the 1 half. Derivative would be 1 half times x to the negative 1 half. Oh, whoops. Did I leave off? I left off my coefficient. All right, so the moral of the story is watch Mrs. Mashagner at coefficients. When I wrote it down over here, I left off the 1 half. Boo hiss. Oh, I would exit. I would do it over, but that's a lot of recording to do over. So let's just fix it real quickly. So were you watching me and saying, Miss Mashagna, you made a mistake? And and if I can edit out the tape, I will. 1/2 x to the negative 1/2. Totally missed the 1/2 in front. All right, so that's going to change my answer. This is how it's going to be. I'm going to have a 1/2. Every one of these is going to have a half in the denominator. So there's a half, and that one gets a half. And now that one's going to be a 1x to the 1/2, or negative 1/2. All right, well, so silly me. So the moral of the story is don't go so fast. Of course, you don't have to worry about writing on a smartboard and remembering to lift your head up high enough to see that there's a 1/2 there. All right, but let's finish this off and get this done correctly. So that one was good. It was adding it with the other one. So now we have 2.5. That's 5/2. I'm feeling better about myself already. And 3 and negative 3. So that'd be negative 6 and a negative 3. That's negative 9/2. Look at all the damage. 1 and then plus 1 over x to the 1/2. All the damage that leaving off a 1/2 can do. So if you want to rewrite it in radicals, this would be 5 and then the square root of x cubed all over 2 minus 9 square root of x over 2 and then plus 1 over square root of x, but either is fine now that you've had to fix it for me. All right, so there's the correct derivative. Make sure you write the coefficient and you don't leave it off. I had it above. I just forgot to plug it in. So here I think we can, so now we can fix this answer. 5/2 x to the 3/2 minus 9/2 x to the 1/2 plus 1 over x to the 1/2. So what was the lesson that we learned from the algebraic analysis? You get the same answer whether you use the product rule, given that you don't leave off a 1/2, or if you simplify first and use the power rule. So the choice is yours on those. That one was a little easier, I think, using simplifying, but there other ones were easier using the product rule, and then we had others we couldn't use anything but the product rule. And the last thing we're going to look at is this equation, and then we're going to be looking at some graphs and some tables. All right? Let's go back to this one. So g of x equals 2x plus 3 times x minus 1 times x plus 3. What's the slope of the normal line to the graph of g of x when x is 2? You have too many terms here for the product rule, right? So product rule is for 2 factors only, not 3. All right, so if we wanted to use the product rule, we'd have to simplify first, and then we could use the product rule with the remaining ones. Here, probably doesn't make any difference which one we use. All right, maybe on this one, we'll just multiply it since we have to multiply it anyway. All right, so g of x equals, I always multiply the last ones, so then I've got the 2x plus 3 ready just to be multiplied by the trinomial. This would be x squared, and then 3 minus 1, that's going to be a plus 2x minus 3. And then when we distribute, we got the 2x times the x squared plus the 2x minus 3, and 3 times the x squared plus the 2x minus 3. So g of x equals 2x cubed plus 4x squared minus 6x plus 3x squared plus 6x minus 9. Right? Yes. Now I'm not trusting my multiplication. All right, so that would give us 2x cubed and 7x squared. And the x's drop out. Yeah, minus 9. Because they're opposites of one another. We got, yep, negative 6 and a positive 6. So our derivative is the easy 2 times 3, 6x squared plus 14x. Right, this one wasn't too bad multiplied, and it certainly wasn't difficult to take the derivative. Right? So in this one you really had a choice, and since you're going to have to multiply anyway, you may as well just multiply the whole thing. It wasn't that bad. So g prime of 2 would be 6 times 2 squared plus 14 times 2. That's going to be 6 times 4 plus 28, or 24 plus 28, which is going to be 52. Okay. 24, 28, yes. All right, so that's some steep slope there. All right, that's the slope of the tangent line. That function is booking when x is 2. Right, and then the slope of the normal line is just negative 1 over 52. That was easy enough once you got the slope of the tangent line. All right, so let's look at some graphs now that we've done a lot of solving and lots of algebraic stuff. All right, so below are graphs of two functions, f of x and g of x. Let p of x equal f of x times g of x. Let r of x equals x squared, yes, x squared minus g of x. Use the graphs to answer the questions that follow. I think I'm going to pause the tape, and part 3 will be the last, and we're going to just do a few last problems. All right, so bye for now.